What's up guys, it's Simon Fiaz and today's video is on AQA A-Level Chemistry Paper 3 2022, June 2022. Which atom in the ground state contains at least one unpaired p electron? It's C, oxygen. They always like to ask about this, like oxygen and its at least one unpaired p electron. Question 7. Complete combustion of this much of organic acid produces this much of carbon dioxide. The same amount of acid required this much of sodium hydroxide for neutralization, which could be the formula of the acid. It's got to be C. This much of organic acid produced this much of carbon dioxide, required this much of that, and if you find that out, divide by 1000 times by 1.00, 0.02. Yeah, so it's going to be HROC COOH. Which substance has no delocalized electrons? Graphite definitely does. Methylbenzene, yeah, the benzene, so it does. Polypropene, well, I know sodium does because it's positive. Can see of delocalized electrons, positive ions, and all of that. So therefore, must be C. Polypropene. Polypropene is a substance which has no delocalized electrons. Question 9. Consider the change that occurs in the shape of the curve for the distribution of molecular energies in a gas. When the temperature of the gas is increased, which is the correct statement about the gas molecule at high temperature? There are more molecules at any given energy. No. There are more molecules with a mean energy. No. There are more molecules with the most probable energy. No. Therefore must be D. The increase in the most probable energy of the molecules. Increase in the most probable energy of the molecules, and that is the correct statement about gas molecules at higher temperature. Which of these correct oxidation states is correct? Chlorine in Cl2 is -1, no is 0. Chromium in that is +7. Well, oxygen -2 times by 7 -14 plus 2 -14 plus 2 -12, so it's going to be +6 then. Yeah. The fluorine in this is -1. No. Hydrogen NaH is +1. Yeah. No. Hydrogen +1. No, in this case, because sodium's in group 1, hydrogen can be -1. So it's going to be F then, C. Because oxygen in this case is going to be +2. Oxygen difluoride is going to be +2, and fluorine is going to be -1. That's a tricky one. So fluorine F2O is -1. Which change to a hydrogen electrode has no effect on the electrode potential? The surface area of the platinum electrode. I haven't even gone through this, so yeah. Same with this. Which cannot function as Bronsted-Lowry acid? Which cannot function as a Bronsted-Lowry acid? Now let me just go back to the definition of Bronsted-Lowry acid. Get my booklet out. Bronsted-Lowry acid. It is proton donor. H plus equals to proton. It's proton donor. So which one cannot function as that? A then, because that's not got a proton. It has got a methyl group, but that's not proton. B, that hasn't got a proton that it can donate. Proton donor. H3O plus definitely has proton. NH4 plus, yeah, from NH3. Therefore, must be A, CH3CO minus. It wants to accept a proton. It can't donate. It can't be a proton donor. Question 14. Strong acid associates in aqueous solutions. Aqueous solution was the pH of this much of this acid. So pH is minus log 10H plus. I've got 2 H pluses. So the first thing I'm going to do is 0.020 times by 2. and minus log 10 of my answer, 1.40. Question 15, equal volumes of two solutions, each with the same concentration mixed together at 298 Kelvin. Which two solutions, when mixed, form a solution with a pH greater than 7? Now, I've got methanoic acid and potassium methanoate. I've got potassium hydroxide, methanoic acid. I've got ammonia, HCl, and that and that. Now, it's definitely not going to be these two, HCl, KCl, very weak. I want to form pH greater than 7. So, I want a really strong acid, ethanoic acid, and potassium hydroxide. So yeah, it's going to be B, potassium hydroxide and ethanoic acid. Question 16, which ionization needs less energy than this process for the first ionization energy of magnesium? Now the second ionization of magnesium, that will need more energy than the process, so we can cross that out. And if I look at the periodic table, magnesium has, where is magnesium in the periodic table? It is, there's group 2, and I've got beryllium, which is above it. So it's going to need more energy because first ionization energy decreases as you go down the group. So that's got a lower one. So this got a higher first ionization than magnesium. I'm left with Al and Ar. Aluminium or Ar. Ar, 18 electrons. And if I look at Al, 1s2, 2s2, 2p6, 3s2, 4, 10, 12, 3s2, 3p1. Magnesium got 3s12, so it's going to be this then. Al gases to Al gases plus E minus, because that's in a different, this is an extra orbital, different p orbital, more shielding, so it's going to need less energy. Whereas argon's got 18 electrons, so with argon it's going to be, yeah, full 3p6 orbital, so 16A. So you can eliminate 2 and then you have to do 50-50 and these two, and then realize, okay, aluminium, because that's got 3p1, so that's going to have more shielding, it's going to need less energy. Which statement is correct about the group 1 elements? The melting point of potassium is higher than the melting point of sodium. Potassium and sodium was potassium, potassium's K, sodium that. No, that's false. Because the charge doesn't, because this is a key fact, the charge doesn't change. Number of delocalized electron pattern doesn't change, it just gets bigger, so the melting point actually decreases. Entropy of atomization for potassium is greater than entropy of atomization for sodium. No, that's false as well. Cesium plus ion has a more negative entropy of hydration than Rb plus ion. Or the second ionization energy of rubidium is lower than the second ionization energy of lithium. Lithium and rubidium, the second ionization energy of rubidium is lower than the second ionization energy of lithium. Yes, rubidium is lower down the group in group 1 than lithium. It's going to have a lower second ionization energy than the second ionization energy of lithium. Question 18. Test for chloride ions in aqueous solution involves adding dilute nitric acid followed by aqueous silver nitrate. What is the reason for adding the nitric acid? To prevent the precipitation of other silver compounds. Question 19. Which pair of reagents react to form a tetrahedral complex? You definitely know that. It's going to be this one. FeCl3 and concentrated HCl, aqueous. Question 20. Cobalt-2 chloride solution changes color when an excessive concentrated hydrochloric acid is added. What type of reaction takes place? Hydrolysis, ligand substitution. It's not going to be hydrolysis, because if it's hydrolysis, you add excess of water. Is it going to be ligand substitution? Definitely not precipitation or redox as well. So yeah, ligand substitution. Question 21. What volume in dm cube of this much of this is needed to oxidize that much of vanadium ions completely? So this much of that is needed to oxidize this much of vanadium ions completely. Well, I've got 0.020 moles per dm minus cube of MnO4 minus. I want to find out how much volume of that is needed to oxidize this much of vanadium ions completely. Vanadium ions is 0.10. And then it's going to be 1 then, because I've got 0.10 moles of vanadium ions. Then I divide that by 5, I've got 0.020, 0.02 here. What volume is needed to oxidize it? I'm going to do 0.020 divided by 0.02. That's 1. So 1. So 21C. Question 22. 2-bromopropane reacts with bromine to form 2,2-dibromopropane. What is the name of the mechanism of this reaction? Elimination, no, because I'd form an alkene. Electrophilic addition, no. Electrophilic, it looks like it, electrophilic addition, but electrophilic addition with alkenes, like bromine and etc. So it's with alkenes to form your colorless dibromoalkane. Free radical substitution, no. Reacts with bromine, 2-bromopropane reacts with bromine, no. No, free radical substitution, yeah. I mean, nucleophilic substitution, no. Therefore, the answer is free radical substitution. Question 22, free radical substitution. Question 23, which compound is formed from bromoethane in a nucleophilic substitution reaction? Bromoethane, methane, ethane, Br, halogen alkane. In a nucleophilic substitution reaction, nucleophilic substitution, so I'm definitely not going to form an alkene. Now, that's an alkyl hydrogen sulfate, and that's when alkenes undergo electrophilic addition with hydrogen halides. No, alkenes react with cold concentration for atom alkyl hydrogen sulfate, so that's not going to be it. Because we don't have an alkene, we've got a halogen alkane. What compounds form for that nucleophilic substitution reaction? CH3CN? No. It's going to be CH3CH2, NH2. Just replace this with NH2. But what happens is, yeah, NH3, ammonia, attacks that breaks, and then you've got your, and then another ammonium molecule attacks, and then you get your NH2 from there. Which statement is not correct for both primary and secondary alcohols? They're easily oxidized to carboxylic acid by acidified potassium dichromate solution. That's false. Primary alcohols are easily oxidized to carboxylic acids, not secondary alcohols. Which compound is an isomer of ethyl ethanoate? Ethyl ethanoate. So this is what? This is a ester, right? Ethyl ethanoate. So first thing is drawing it out. I've got ethyl ethanoate. So methane, ethane. C double bond O. And I've got O here. Methyl, ethyl. I think this is right. So which one's it? Isomer of that? Butyl methanoate. Butyl, I have a butyl group here. And methanoate. No. That's an isomer. Methyl propanoate. I've got a methyl group and then propanoate. Yes. Yeah. Because think about butyl. What was it called again? Butyl methanoate. I put butyl group here. methyl ethyl. Yeah, I can't do that because I'll do methyl ethyl propyl butyl, and then what am I going to have on the left hand side? Nothing. So it can't be that. Methyl propanoate. Yes, I can have a methyl group here that goes here, and then I've got no this. Sorry, that this goes here. Methyl. I just need one CH3, and then I have methane, ethane, propane, propanoate. Yeah. Let's look at the other option. Methyl butanoate, methyl, and then butanoate. No, I definitely can't go butanoate. And propanoic acid. No, I've got an extra dot. So no. So methyl propanoate is the answer. Which compound is an amide? Now that's a nitrile. Okay, I've got C. It's definitely not going to be that as well. If for B and D, well, an amide, so yeah, it's going to have the C double bond O and the NH, right? And that's exactly what I'm looking for. That's just got the NH. Amide. It didn't say amine, it said amide. So yeah, C double bond O, NH, and therefore it's going to be B. Question 27, subaryl chloride, ClOC, bracket CH2,6COCl, is commonly used in the manufacture of polymers. Which compound can form a polymer with subaryl chloride? It's going to be A. The one with the two NH2 groups, right? It's definitely not going to be B because that's already got that. Why would I react with that? C, no, I've only got one. I need two. D could, I could see most students falling for that instead of A, because of two carboxylic acids group, but no, it's going to be two NH2 groups. So yeah, that will form polymer. Which polymer is not hydrolyzed when heated with aqueous alkali? Which polymer is not hydrolyzed when heated with aqueous alkali? Polypropene. Kevlar is hydrolyzed, 966. Yeah, you should know the names of these and you should be like, I've heard of that, I've heard of that, I've heard of that, and those three are hydrolyzed, so therefore must be this. Polypropene, bracket propene, and this is the polymer which is not hydrolyzed when heated with aqueous alkali. Question 29, which is the main species present in aqueous solution of aspartic acid at pH equals 14? pH equals 14, that tells me I've got a low concentration H plus ions because I've got a very high pH. So it's not going to be A, and it's not going to be B. I'm left with C and D. It's going to be D then. Yeah, because it wants to accept their H pluses, right? It's going to be D. Question 30. Which type of reaction is not involved in this reaction sequence? COCH3 to COCH3NO2, so that is nitration by electrophilic substitution, so that is involved. Yeah, then I'm going from this to that. So I've added an OH, so that's hydrolysis. No, that's not hydrolysis. So definitely not C. D, reduction. Yeah, definitely not that. So I'm left with esterification and hydrolysis. Well, esterification was heating a carboxylic acid with an alcohol. Let me just double check this, but yeah, I'm pretty sure it's heating a carboxylic acid with alcohol to form ester plus carboxylic acid to ester plus water. So carboxylic acid plus alcohol, ester plus water. Yeah. Where's the carboxylic acid? Where's ester? Where's all of that? Carboxylic acid plus alcohol to form ester plus H12. Carboxylic acid. Oh, never mind, that does occur. Esterification does occur. And then that's how you get your ester then. So it's hydrolysis, which is not involved in this reaction sequence. Hydrolysis. Question 31. Which pair of reagents does not produce ethanol? Methane, ethane, bromoethane, and sodium hydroxide. Ethanol, well, methane, ethane, that will form ethanol, does not produce ethanol. Then I've got that and sodium hydroxide. And sodium hydroxide. So what will happen? Yeah, that won't. B won't. D, yes, because that's obviously an aldehyde with the sodium borohydride, and you can go back to the alcohol, and yeah, you will form ethanol. C, yes, because what you're doing is, yeah, you will form ethanol. So the answer is B, that. Question 32. Which type of interaction between polypeptide chains is mainly responsible for maintaining the secondary structure of protein in the form of alpha helix? Hydrogen bonds. Just need to know that. That's just like an A1 question. How well you know your content. Hydrogen bonds between polypeptide chains. Question 33. Which statement about this is correct? It decolorizes bromine water. Is a component that reacts with HCl. Definitely doesn't decolor bromine water. Where's the carbon-carbon double bonds? I can't see any. Only can see is C double bond O bonds. Yeah. It is a component of DNA. Yes it is. Insoluble in water. No, sorry. Which statement is correct, yeah? Is a component of DNA? No, it's not. If it's a component of DNA, like guanine, thionine, cytosine, thymine, all of those, it's not. It is insoluble in water. Insoluble in water and reacts with reacts with HCl. It definitely does react with HCl. Insoluble in water? No, it is soluble in water. It's not insoluble in water, so that's false. Decolored bromine water, that's false. What was that second one about? It the component of DNA, that's false. It is insoluble in water, that's false. It reacts with HCl. Question 34. Which compound can be dehydrated to form an alkene? Dehydrated to form an alkene? Well, alcohols can be dehydrated from alkenes. Remember, what's it called? That practical cyclohexanol to cyclohexene. Alcohols can be dehydrated to form alkenes. So I'm just looking for an alcohol really, because that's all the info they gave us. A, that's an aldehyde. B, that's carboxylic acid. C, that is an alcohol. D, that's an ester. So C must be C. Question 35. Which compound is not a 2-amino carboxylic acid? So, well, obviously all of them got COOH groups. Which one is not a 2-amino carboxylic acid? Well, A definitely is. Start from there, 2-amino here. I look at B, start from there, that's a 3-amino. That's not 2-amino. Look at C, that's 1. That's obviously going to be in the second one, so that is 2-amino. I look at D, 1, 2, therefore must be B. That is not a 2-amino carboxylic acid. And that is the end of section B, aka the multiple choice questions.